So, now that you've seen the videos on how we do this, you've got a good idea as to why we generally buy our patch cables instead of making them, right? Problem is, in every situation, you can't always buy a pre-made patch cable. Sometimes you have to be able to pull that cable through a restriction of some kind that is going to preclude having an end on that cable. Okay? Also, long patch cables get very expensive very quickly. So we generally, in the field, make our own. Now, we are right at the cusp of a major change in the building automation systems where we are currently using a very limited number of patch cables, but here within a year or two, we are going to multiply the number of patch cables immensely. Because at this juncture in time, our controllers on the far ends of our network, our VAV controllers, our air terminal unit controllers, typically talk on what is called, is a 2-wire bus that we just put a couple of screws in and clamp it down and it's good. But more and more companies are coming out with VAV controllers that use a network connected cable jack. So this skill will become progressively more and more essential for our students and technicians. Okay? Now, I use 568B because that's what I was taught. It works well, it works consistently, it's what I'm used to. But like he said, as long as both ends of the cable are the same, it will work most of the time. So the challenges with that, I have seen people who make their cables so that they don't split up the wires, they just go right down and just go the white one, the colored one, the white one, the colored one, the white one, the colored one, straight down the row. And sometimes that works fine for short length cables and for low speed communication cables. But if you want to be able to communicate at the full capability of your device, if you need to run more than a handful of feet, then you really do need to split the conductors so you don't get that crosstalk issue. And that crosstalk issue is just inductance in the cable from one side of the signal getting confused with the other. It's problematic at best and will shut down your network at worst. Okay? So, this is our color standard. If I could rotate this TV 90 degrees, that's how I would do it. So, while you're building these cables, what I would suggest that you do, now, he talked about, nicking your cable and then pulling down the pull string and everything. Sometimes that's necessary, sometimes it's not. If you don't cut the insulation on the cables, you don't need to pull the pull string down. I usually cut off about 2 inches of the outer jacket of the cabling. That way I've got plenty of length to work with, but I don't have to cut more if I don't need to. Cut off the pull string, just like he said, you don't want to mess with it any more than you have to because it is annoying, okay? Then you're going to hold in your dominant hand, or offhand, not your dominant hand, the base of the jacketing. And you're going to peel out the 4 bundles of conductor. You're generally going to want to have your orange on your left side, green, blue, brown, as you're looking down on it, holding it, okay? So if this was my cable, I would be holding it like this here at the base. Then I'm going to untwist all of my wires. I just untwist them all. Sometimes you can do it in order, sometimes it helps, sometimes it doesn't. But I personally just untwist all of them all the way to the base of the jacket where I'm holding on to. You don't want to go any further back because again, that ends up with that crosstalk issue. The further we untwist those cables, the worse our communication will be using that cable. So untwist only to the edge of that jacket if you can. Okay? Then I'm going to straighten out as much of the curve as I possibly can. I run the wire across the tip of my thumb, of my dominant hand, and give it kind of a positive curve in one direction it takes out some of the wave that is inherent from the twist. This is significantly easier to do on Cat5 and Cat5e than it is on Cat6 cable, because the Cat6 is a thicker cable and it is also a more tightly twisted cable. Okay? Just general tips here. Okay? Then I lay it out in the order. I leave it the full length. I get it all laid out in white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. You will probably hear me in the lab when we say this, that it will appear that I change the way the colors go. I don't, it's just the way I was taught, because I was taught that this is orange, white, not white, orange. So I will confuse you on that. I warn you ahead of time, I do apologize. Okay? So you get them all lined up. Just get them in the rough order, fan them out so they look nice and pretty. You've got some space between them. Still holding right at the base of the cable. Then, from one side or the other, collect them up so they are a nice flat ribbon-looking cable. Have them all nice and parallel like your fingers. Okay? Then, this is the point where I start bending them back and forth, just like the guy in the video did. That does work well to get them in position. And I squeeze progressively down closer and closer to the base. Because this point, these 4 wires here, your greens and your blues, there's a crossover there. You're splitting these 2 greens. So there is going to be a cross there, and it will be hard to work with. So the closer down to the jacket you can get that crossing, the easier it will be. Okay? Then the length that he suggested is about what I do, about half the length of your, or about the length of your thumbnail. Cut off the excess. Pick up the connector with your dominant hand. Hold it so that the little clip portion is down, and slide your cabling in. There are ridges inside there, so if it doesn't slide in, you might have to shift sideways a little bit. But as long as your wires are nice and tight together, it should slide on fairly easily, up until the point where your first wire reaches the end of that connector. At that point, that's when you may have to push a little bit to get the others to line up. That's okay. Also, you're going to be pushing on your jacket as you're doing this and shoving it further into the connector so that it gets in that crimp. Does that make sense so far? Does that clarify a little bit there, what he went through? Okay. Our crimpers are the same Klein ones that he was using. There's nothing wrong with them. You will have to open them when we get over there. Those, we have one of those for each college. You're taking those home with you. Same with, we have one cable tester for each college. So you're going to do ends on both wires and then test it. Okay? Make sense? And I absolutely agree with him. Do not crimp it just once. Crimp it at least 2 or 3 times. And the harder you can squeeze those pliers, the better. Okay? It is designed so that you cannot squeeze too tight on those pliers unless you actually manage to break the pliers themselves. Questions?
Go over again. There was the transmit and receive.
Okay. So, hang on, guys. Bruce has a question. So, Bruce, could you say your question?
If you could just spend a minute going over the purpose of each of the wires and why they were twisted. And then I heard somebody say transmit and receive, and I didn't follow that piece.
Okay. So anytime we have networks, well, most of the time when we have a network, we have a dedicated pair of wires that send signal. It's always an outgoing signal from the source. And that pair, obviously, and then on the other side, we have an incoming pair. So we send signals out on one, we get signals back on the other, and Brian's computer goes to sleep. There we go.
It's like chill water supply and return.
Excellent example.
It's just a different flow.
Excellent example. So for us, the orange and the green wires are those pairs. Okay? And if I remember right, it's the whites that are transmit, and the whites are receive, and the greens or the solids are transmit. One or the other. But anyway, we split them apart so that the active pair doesn't have that risk of collision. Because just like the wires in a transformer, where we've got those opposing signals that cause our induction, well, we don't want that in the wire.
I think you had it right the first time. Here we go. Here's a slide that might show.
There we go.
Yeah, it's a straight.
There we go. Striped or transmit, solids or receive. Thank you, Brian. All right. Questions?
Okay.
I don't know if I want to ask this here now, but you mentioned that this is growing because of the smart actuators and sensors.
Not necessarily the smart actuators and sensors, just smarter end controllers.
Versus
But-
two-wire.
Correct.
Going back to a controller. Now, why would wireless not be a big contender?
That's a big, very big subject.
That's one of the questions I was gonna ask this weekend.
I guess I understand the drawbacks of wireless, but I don't know if that's the right answer.
This will
So,
win first. Yeah. This will come first, and then
yes.
when
It
they
seems
get
more
first-
robust, it's less interference, it's less noise and RF noise, blah, blah, blah.
there are a couple of considerations there. One is security. If it is a hardwired network, you have to be able to physically connect to it to interfere with it. Well, not to interfere with it, to hack it.
If you say, if you
generally.
say the word wireless on an Air Force base, there'll be 5 SPs crawling down your back in a minute.
The other concern is there are most of the companies that are making controls in the industry right now, if they're making a wireless control package, they are using one of the common wireless control protocols that we run into in home automation as much as anything else, Zigbee or Z-Wave. And there is nothing wrong with these protocols individually. The challenge with them is they happen to use the same broadcast frequency as the wireless networks that IT uses. So the standard issue is a company comes in, they install a wireless communicating system when the building is completely empty, and it works fine when they leave. Well, building's done, the IT guy shows up, starts hanging his wireless access points into the ceiling, and they start dropping off sensors and controllers left, right, and center. Because now we have something else talking at that same frequency. So, the control guy comes back in, sees the problem, boosts his signal up a little bit. Okay, everything's back online. Then the president calls the IT guy and says, hey, I can't get wireless on my phone in my office. You fix it or you're fired. And the IT guy goes, okay. Well, my dial goes up to 11, and away we go. And now the Zigbee and the Z-Wave, unless properly configured, have very hard times communicating. Now, there are some control product lines, like EasyIO, that are just saying, okay, we're not going to create our own separate network. We're just going to jump on IT's network. I mean, that's what everybody's doing with their Ethernet-based VAV controllers anyway. They're still going to have an IP address. Well, we've got these wireless signals running throughout the building. Why not? There are security concerns associated with that, but if you have an IT department that is on top of it, they can mitigate a portion of those concerns.
It also really depends on the use case application and where you want your data historian to be and the critical nature of the data and the types of things that are being managed. So
Absolutely.
there's just a lot of threads to that. But this is going to win first.
It will, because it's trusted.
Yeah.
Absolutely.
And I've been told that the price is not an advantage on wireless, even though you have to lay out all the cable and pay for labor.
Generally
That's what I'm
speaking,
saying.
true, because we still have to pull power to our controllers more often than not. So it's almost as easy to run 1 or 2 wires right now, yes. It's almost as easy to run 2 wires to it right now as it is, you're going to have somebody up there in the ceiling anyway, sort of deal. Not exclusively, but.
Would you add a discussion of Z-Wave and Zigbee to this as you were giving it to your technicians, given what we're seeing in the industry?
Yes.
Most of the textbooks that you find talk about Zigbee and
Z-Wave.
Z-Wave.
Okay.
They won't go into great detail, but they'll talk about
Right.
mesh
Kind of that it
technology and that kind of
exists,
stuff.
sort of thing. I personally would much rather see Zigbee and Z-Wave stay over in the home automation end of things, just because of the problematic nature. You have to have people who really understand wireless networking to successfully implement Zigbee or Z-Wave in a commercial building. That's my 2 cents, and it is an opinion. There are many people who completely disagree with me, but that's been my experience on it. Okay. Mark, before we jump into the lab, you had a question on ports.
Yes.
So it's very similar to this discussion we're having right now about regular wireless versus Zigbee and Z-Wave. So if the easiest way to think about ports, or the analogy that I am working on, is radio signals. Everybody still have a classic radio in your car that picks up either AM or FM? We haven't phased those out completely yet? Okay. So, if you think about it, our networks are very similar to radio signals. We're always sending out information on them. We're always receiving information on them. It's just our choice as to what station we're going to listen to. Our ports are very similar to those stations or those channels. And there's that same in wireless. Even though we're talking on a given frequency, there are also channels within it. So standard ports may be port 80, which is our standard web port, or 443, which is our secured web port. And there's a whole stack of these ports.
What's the advantage of using multiple ports?
It means you could have multiple different processes on a computer successfully communicating on the network at the same time. So, for example,
So it
Brian-
doesn't affect the speed of the cable, but the throughput?
it's going to slightly affect the loading of the network. So this computer, for example, right now, if we were on the network streaming a video on YouTube, and at the same time we are using a voice over IP chat protocol. You know, maybe we're playing a video game and chatting with our friends at the same time. They need to be operating simultaneously on the computer, right? Operating simultaneously on the network. So we just kind of split them out and say, okay, program 1, you listen on this port. Program 2, you listen on this port. Now you can work together and not step on each other's toes.
But isn't the bigger issue from a control standpoint is like when firewalls close ports that
Yes.
systems need?
Yes. That is our specific, our most common issue with port numbers is we have to tell the IT guy, my information or my system communicates on these handful of ports. Please don't block it.
And from the backward side, troubleshooting and being able to know where your problem really is. So if it's
Absolutely.
BACnet and STP, you're going to be in one place. If it's somewhere else, it's a different place.
Yes. Does that, you're looking, you're thinking really hard, Mark. I'm worried.
Made a couple points.
I gotta digest this.
Okay. We can come back to it tomorrow morning. How about that?
Do you have one of those charts that breaks down, you know, like it shows like the 4,000 band, the 0 to 100 band, you know, they're color coded and it's kind of
I know what
like a
you're talking
dummies
about.
guide.
No, I don't have
I mean,
one.
that's like the best one-page kind of dummies guide. It helps, if I can understand it, anybody can understand it. So it might help.
I guess my problem is I've always looked at radio signals as kind of analog, with different wavelengths and frequencies, keep them naturally separated. You're
Right.
taking digital signals, you're throwing them across the same physical media, and you're saying they're not going to collide if we use different ports.
So you're right, and it is, ports are for high-level thinking, our usage. Do you have a,
Well, I'm gonna put it in a really
Well, that's
this is the
good.
way I
Okay.
think, so all I'm just saying is, if you wanna listen to talk radio all day long, then you know the channel that you wanna listen to.
Right.
If you wanna listen to classical music, then you don't go to the talk radio channel.
But that channel is like a filter, I think. I mean, in as much as it's letting sizes oral through.
Okay.
No.
So it's
I know
But
what
I'm
you're
just
doing.
trying to say, for the purposes of the ports, there are different types of conversations taking
It's not quite
place.
that way though.
So it's just knowing that what's running on that is gonna be
What?
different stuff.
So how can you play your video game and talk at the same time?
Yes,
Maybe it's
so-
just radio.
I'm saying it's happening at the same time, but in reality, it's not happening at the same time. For our purposes of using that software, it is the same time. But below our software, we've got the operating system, which is talking to the network card. And somewhere in that stacked OSI model, bad word, I know, trust me, you'll learn to dislike it or love it, one or the other. There's no in between.
It's a necessary evil.
It moves down the stack. It says, okay, these port numbers, and it's just kind of a sequencer, like when you're merging with heavy traffic.
Setting priorities.
That's kind of how it goes. Peter?
This may be beyond the scope of this session, but what kind of issues come up in managing a lab, a BAS lab, interacting with the campus network?
It depends on
IT
how
guys?
you have to tie it into the campus network. So
Right.
most of the time there are a lot of issues when you start dealing with your campus IT.
Permissions,
Permissions and everything. So that gets down to how you're designing your lab and your network, or your lab's network. If you can get away with having your network completely separate from IT's, if you don't need basically internet access, if you don't need to access their servers or anything like that, I fully encourage you to do it just to avoid that IT hurdle.
Yeah, they carved out a network for me, and if I need support from outside, like from a vendor,
Mhm.
I need to give them a VPN.
That's the other
To
option.
tunnel through to my
Right.
network.
My network over there is completely separate. Mine doesn't have any
Even
internet
physical.
access. There is no physical connection.
They won't
That
allow me to.
is the easiest way